Welcome to JEE. Now we are continuing the session pair of straight line chapter. In first session we have completed the introduction part of pair of straight line, and the second one the angle between two pair of straight lines. Now the topic name is pair of parallel and perpendicular lines. Pair of parallel and perpendicular. Parallel is nothing but the lines which are at equidistance if you check anywhere, and the perpendicular is nothing but, this is nothing but perpendicular, the lines which are intersecting at one point, the angle between two lines is 90 degrees. This is nothing but parallel and perpendicular here. So in the point 1, you have to remember each and every point for the pair of straight lines chapter. These are the most important points for your JEE mains examination. So the first point is the equation of pair of straight lines passing through the point. Here the pair of straight lines are passing through point, not passing through origin. Passing through a point, that is x1 comma y1, and parallel to one more set of pair of straight line ax square plus 2hxy plus by square is equal to 0. Then the condition will be, here observe clearly, saying the first point is a pair of straight lines, this is x axis and this is y axis, and a pair of straight lines is passing through one more point, that is x comma y, and these two lines are parallel to one more set of parallel lines. This is one more set of parallel lines, you can write like this. The blue lines are parallel to the red lines here. So this is also one more point, that is this is x1 y1, this is x2 y2 here. So if one set of parallel lines are parallel to one more set of parallel lines, this is a1x plus 2hxy plus x square plus 2hxy plus b1y square is equal to 0, and this is a2x square plus b2 2h2xy plus b2y square is equal to 0. Here these two set of parallel lines are parallel to each other. Then the condition for this one is, this is the important condition here. So that is a into x minus x whole square plus 2h into x minus h into x minus x1 into y minus y1 plus b into y minus y1 whole square, where x1 y1 be the point passing through a one set of parallel that is given here. So when two set of parallel lines are parallel to each other, then the condition for the equation of those parallel lines is a into x minus x1 whole square plus 2h into x minus x1 into y minus y1 plus b into y minus y1 whole square. Here this x1 y1 values are real values, point values here. So x and y, b and y, a are variables here. So the second point here, the second point is, this is all about the first point, and the second point, understand carefully while teaching the class here, the equation of the pair of straight lines passing through origin. Here equation of pair of straight lines passing through one point, and here the equation of straight lines passing through origin and perpendicular to one more line. Then the condition is, here equation of pair of straight lines are passing through origin and perpendicular to one more set of parallel lines, then those are called, then the condition for that one is b into x square minus 2hxy plus ay square. So here this pair of straight lines are passing through origin, and this pair of straight lines are perpendicular to one more set of parallel lines, that is ax square plus 2hxy plus by square is equal to 0. Then the condition for that one is b into x square minus 2hxy plus ay square. You have to remember the condition for parallel lines, you have to remember the condition for perpendicular lines, parallel and perpendicular. And the third point is the equation to the pair of straight lines passing through a point. Here passing through a point, here passing through origin, and here passing through a point, and perpendicular to the pair of straight lines. Here the condition is, here this is also perpendicular and this is also perpendicular. What is the difference between both these points here? So here the point, pair of straight lines are passing through origin and perpendicular, and here pair of straight lines passing through a point, here origin, here point, and perpendicular. These two points are same, but when comes to it is passing through the point, here passing through origin, here passing through one point here. That is the most difference here. Here it parallel and passing through a point here. So now the pair of straight lines are passing through a point here. So for example, I am erasing this one, x axis, y axis. So I am taking, this is an x axis, y axis, this point is x comma y, this point is x comma y. Now this is x axis, this is y axis here. So now these two lines are passing through one point, that is x comma y, and these two lines are perpendicular to one more set of parallel lines, that is one more point, that is x2 comma y2. This set of parallel lines is a2 x square plus 2h2 by xy plus by square, and the condition for this one is b into x minus x1 whole square minus 2h into x minus x1 into y minus y1 plus a into y minus y1 whole square. You have to remember the three conditions. Lines are parallel to perpendicular to the pair of straight lines. Here this is a line parallel to one more set of pair of straight lines passing through a point here. This is perpendicular and passing through origin, and this is also perpendicular passing through one point here. These are the three condition of straight lines, condition of lines you have to remember for the pair of parallel and perpendicular lines topic here. And the next topic is here the common line to a pair of straight line. A line we are taking here, a pair of straight lines and pair of straight lines we are taking here. Here a common line I am taking, a common line to a pair of straight lines. Common line to a pair of straight lines is nothing but a single line, a single line. For the first point for that one is, if the pair of lines a1 x square plus 2h1 xy plus b1 y square is equal to 0, and a2 x square plus 2h2 xy plus b2 y square is equal to have one line common, then the condition will be, understand very carefully here. So I am representing in diagrammatical way. So I am taking the coordinate axis here. This is x and y, this is origin 0 comma 0, and here I am taking a pair of straight lines passing through one point. This is pair of straight lines here, and I am taking one more pair of straight lines here. This is also one more pair of straight lines here. If you observe this pair, here two lines are there, red lines are there, and here blue lines are there. Here for these two pair of set of pair of straight lines, this blue and red line is common for both the pair of straight lines. So that's why here this is a common line, this is a common line. Here two set of pair of straight lines are there. This is one set and this is one more set here. For this one, the equation is a1 x square plus 2h2 xy plus b2 y square is equal to 0, and for this two set a2 x square plus 2h2 xy plus b2 y square is equal to 0. Here this is one set of pair of straight line and this is also one more set of pair of straight lines here. So for these two pair of set of lines, one line is common for two set of pair of straight lines here. So for that one, the condition for that one is modulus of a1 2h1 a2 2h2 into 2h1 b1 2h2 b2 is equal to a1 b1 a2 b2 whole square, or this is the determinant value. Now if you want to write in a condition way, a1 b2 minus a2 b1 whole square plus 4 into h1 a2 minus h2 a1 into h1 b2 minus h2 b1 is equal to 0. This is the condition you have to remember for two set of pair of straight lines is having one common line for the two set of pair of straight lines here. These are the two conditions you have to remember. You have to remember every time while solving pair of straight lines problems here. And the next point is, if one of the lines represented by a1 x square plus 2h1 xy plus b1 y square is equal 0 is perpendicular to one of the lines represented by a2 x square plus 2hxy plus by square is equal 0. Here one set of pair of straight lines is given here and one more set of pair of straight lines are given here. One line is perpendicular to one line. Here one line is common and one line is perpendicular to, if you take one line is perpendicular here. So this is perpendicular to one more set of pair of straight lines. Then the condition for that one is in the determinant value, in the determinant manner, a1 to h1, b2 to minus 2h2 and a2h1 b1 minus 2h2 a2 is equal to a1 b2 b2 a2 whole square. This is the determinant value and the condition for that one is a1 a2 minus b1 b2 whole square plus 4 into h1 a2 plus h2 b1 into h1 b2 plus h2 a1 is equal to 0 here. This is the most important condition for a common line is having perpendicular. Here a common line is having common to two set of pair of straight lines. Here one is parallel to perpendicular here. This is for common here. So these are the 2 points for the common line of a pair of straight lines. Here you have to remember the 2 points and the one more point here. If the pair of lines a1 x square plus 2h1 xy plus b1 y square is equal 0 and one more set of pair of straight line 1 2 here. So for this is not a diagram for that one. Okay, assume that this is one set of pair of straight lines here, a1 x square plus 2h1 xy plus b1 y square is equal 0 and one more set of pair of straight line is a2 x square plus 2xy plus by square is equal 0. Here two set of pair of straight lines are there and are such that they have common line, one common line and remaining lines are perpendicular. Remember this point here. This is x axis, this is y axis. I am taking, this is one set of pair of straight line and one line is common and other line is perpendicular. Other line is perpendicular. This line is common. This is one set of pair of straight line and this is one set of pair of straight line. The red line symbol, the red lines will indicate one set of pair of straight line and the blue lines indicates second set of pair of straight line. Here for this one line is common to two set of pair of straight line. This line is common to two set of pair of straight line and other line is perpendicular to one pair of straight line here. So for that one condition is h1 into 1 by a1 minus 1 by b1 is equal to h2 into 1 by a2 minus 1 by b2 here. So you have to remember 3 points for the pair of parallel and perpendicular lines. You have to remember common lines to pair of straight lines for 3 conditions here. This is for common line, this is for perpendicular, this is common and perpendicular both here. So this is all about the common line to a pair of straight lines here. And the next topic is types of triangles related to pair of straight line. Types of triangles related to pair of straight line. In that, the first point is the equation of pair of lines passing through. The equation of pair of lines passing through origin. This is the important point. Origin and forming an isosceles triangle. Nothing but, first of all, I am taking coordinate axis. This is coordinate axis and a pair of straight line passing through origin. He is saying a pair of straight line passing through origin. So I am taking, this is the pair of straight lines, so passing through origin, and I am framing an isosceles triangle with a line ax plus by. A line, that is a line I am taking here. This is a line. This line is ax plus by plus c is equal to 0. By this line, this pair of straight lines framing an isosceles triangle here. So this is a line intersecting, this is ax plus by plus c, line intersecting the pair of straight line. This pair of straight line equation is ax square plus 2hxy plus by square is equal to 0. This is a equation for these two pair of straight lines here. So this is a equation for the red line, that is a straight line. The straight line expression is ax plus by plus c is equal to 0. This straight line intersecting the pair of straight line, by intersection of these straight lines to a pair of straight line, here framing an isosceles triangle. These two lines are equal and this is unequal here. So this is a triangle framed here. This is a triangle framed here with a line ax square plus bx plus ax plus by plus c is equal to 0. And the condition for this triangle is, then the condition for this triangle, ax plus by whole square minus k into bx minus ay whole square. This is the most important condition, ax plus by whole square minus k into bx minus ay whole square. You have to remember this condition for a pair of straight lines passing through origin and a line ax plus by plus c is intersecting the pair of straight lines. By the intersection of this line, it will frame a isosceles triangle. This is the condition for that one. If you substitute in this condition, if you substitute k is equal to 1, what will happen? The triangle will become right angle triangle. The first condition is right angle triangle. The first condition is, if you substitute k is equal to 1, what will happen? Ax plus by whole square minus bx minus ay whole square is equal to 0. This is the condition for if k value becomes 1, then the triangle will become right angle triangle here. Then if k is equal to 3, if you substitute the value k is equal to 3 in place of k is equal to 3, then the triangle will become equilateral triangle. Equilateral triangle is nothing but having all sides are equal. This is the second point here. And if you substitute k is equal to minus 1 by 3, 1 by 3, then the triangle will become isosceles obtuse angle. This is the three types of triangles framed by the condition when a pair of straight line is intersecting the line, that is ax plus by plus c is equal to 0 to a pair of straight line, that is ax square plus 2hxy plus by square is equal to 0. This equation for these two lines, this equation for this equation for this line, this equation for these two lines. So by intersection of this line, it will frame a triangle here. So now the second point for this one is the triangle formed by the pair of straight line to ax square plus 2hxy plus by square is equal to 0. This is the two pair of straight lines here, and the line lx plus my plus n is equal to 0. Here I am erasing this total condition here. So this is x and y dash here. So this is a coordinate axis 0, 0 origin, and a triangle is formed by the pair of straight lines ax square plus 2hxy plus by square is equal to 0, and the line lx plus my plus n is equal to 0. Here for this, here the line ax plus by plus c is equal to 0. Here the line that is lx plus my plus n is equal to 0. Here he is not saying whether it is passing through origin or whether it is passing through a point here. So I am taking point. The previous case is it is passing through origin, but here he didn't mention anything it is passing through origin or not. So that's why I am taking a point, that is x comma y here. So this is the pair of straight lines. These blue lines indicates pair of straight line, that is ax square plus 2hxy plus by square is equal to 0. These two lines indicates the two blue lines indicates the equation, that is ax square plus 2hxy plus by square is equal to 0, and the red line indicates lx plus my plus n is equal to 0, that is a straight line equation. This is only straight line is equation, a straight line intersecting the two pair of straight lines. This line is intersecting two pair of straight line, so that it can frame a triangle. This is a triangle here, this shape is called triangle here, this is a triangle. And now the condition for that one is the condition for equilateral triangle. The condition for equilateral triangle is ax square plus 2hxy plus by square is equal to 0 generally, but if it is equal to lx plus my whole square minus 3 into mx minus ly whole square, then the condition, if the condition satisfy this one, then it is an equilateral triangle. And second one is isosceles triangle. Isosceles is nothing but if h into s square minus m square is equal to a minus b into lm. If the condition satisfy this one, it is an isosceles triangle. And the third one is right angle. If a plus b is equal to 0, the sum of coefficients of x square and y square terms become 0, then or S of Lm is equal to 0. S of Lm is nothing but if you substitute L and M values in this expression, it will become 0. Then the triangle is said to be right angle triangle. Here observe clearly, this A, B are quotient of x square and y square respectively. 2h is the quotient of xy, and Lx plus My are line values from straight line here. Now here h is the quotient of xy, L and M are quotient of x and y of straight line here, and a minus b is nothing but a value, b value from quotient of x square and y square here, and L and M are quotient of L, M, x and y of a straight line here. I am explaining each and every values here. A plus b is nothing quotient of x square, y square here. For example, 2x square plus 2hxy 4xxy minus 2y square is equal to 0. Here a value is 2, b value is minus 2. 2 minus 2, if you add two values, 2 plus of minus 2, 2 minus 2 is nothing but 0. Then the triangle is said to be, you can say that is a right angle triangle. In that way, similarly you can find for isosceles, equilateral for this one. Here the line is ax plus by plus c, here the line is lx plus my plus n is equal to 0. Here these are all about the pair of straight lines. Here pair of parallel perpendicular lines, 3 points are there, and common line to a pair of lines, 3 points are there. You have to remember the determinant value and the condition value for this one. Here for this one, pair of straight lines passing through a point and parallel to one more set of parallel lines here, and here pair of straight line passing through origin and perpendicular to one more set of parallel lines here. Here pair of straight lines are passing through point and perpendicular to one more set of pair of straight lines here. Now common line to a pair of straight lines here. Here the pair of straight lines are one line common, then the condition for this one here, and if the pair of straight lines represented by perpendicular to one more line here, this is the condition. These are the two conditions. Here one line is common and one line is perpendicular here. If the types of triangles formed by the pair of straight lines here, the equation of pair of straight lines passing through origin and a line is intersecting two pair of straight lines, a triangle is formed here, and here a pair of straight lines passing through any point or origin here, a line Lx plus My plus n is equal to 0 is intersecting the pair of straight lines, so that triangle is framed here. So for this one 3 conditions, for this one 3 conditions. You have to remember each and every condition for all the points related to pair of straight lines here. In next section we will discuss about some more points here. Thank you.